Okay, question 6E3 from Statistical Rethinking, second edition, pretty basic one. So we are meant to list the four elemental compounds, or I've been calling them structures or causal structures or motifs. Any of these are fine, and explain the conditional dependencies of each. Okay, so so the four fundamental structures are presented here in two different ways. One is in this table, in kind of the inline representation of it, as well as the figure from the book that I've just copied and pasted here. Okay, so let's go through these in order. So the first one is the fork, okay, where x and y, or any two generic variables for that matter, have a common cause. Okay, so that's represented here. The middle variable for each of the pictures here is z, and I've just used f to denote fork, but same structure. So what we're meant to do is to think about the relationship then between x and y in each of these scenarios. Okay, so in the case of a fork, x and y are going to be related to one another. Why are they going to be related to one another? Well, because they're both responding to the input of f, right? So as f goes up, x and y will, or as f changes, x and y will change, maybe not in the same direction, or maybe in the same direction, but their change in response to changes in f will be coordinated, and so they will be associated. Okay, if I condition on f, in other words, conditioning is akin to, or one way to think about it is holding the f variable constant, and this is what we do when we include f in a regression. Well then, x and y become independent, and so that's what this notation here means. X is independent of y given f when I condition on f. Okay, and so if this was a regression, if y was the outcome and x was a predictor variable, if f was affecting both of these, then we would predict that by having both x and f in the regression, there would be no association between x and y, right? Because we've conditioned on f in this case. If we omitted f from that regression, then there would be an association between x and y. Okay. Next is the pipe, or I often call this the mediator, okay, where x affects y, excuse me, x affects y via some other variable, m, I call it, or z in the depiction down here. So again, let's think about this. So in the data set, it will seem as though x and y are associated with one another. Okay, well, and the reason is because x affects m and m affects y. So in kind of a drawn out way, x is in fact causing y, even though it's happening through m. All right. So when I condition though on m, I am holding it constant, and if I hold it constant, it means that it is no longer, I can move x up and down as much as I want, and m is not changing. Well, if m is not changing, then the movements of x are no longer causing a response in y. Okay, and so that means that even though x and y would be related, they become independent. This upside down t, x and y become independent after conditioning on m. All right. So what's important to recognize here, or one thing that's important to recognize here, that in both forks and pipes, conditioning on this middle variable, in both forks and pipes, x and y are dependent on one another. They are not independent, but they become conditionally, or they are conditionally independent. In other words, they become independent when I condition on this middle variable. Okay. Now that is so in the case of the mediator, for instance, if I include just x and y in the regression, so y is the outcome, x is the predictor, we will find a association between x and y. Okay, and so if I include m in the regression as well, in other words, I'm holding m constant here, then I'm going to diminish that association. I say diminish, not eliminate, because if x has other paths to y, then x will still have a, it will still have an association in the regression. But if it was only x, if this was the entire causal structure, conditioning on m would then eliminate the causal effects of x on y, or apparently the regression would seem to say that x had no effect on y. Okay, once you hold m constant. Okay, so now the mediator is very much opposite of the fork, or I'm sorry, the collider is very much opposite the pipe and the fork. Okay, so whereas the fork and the pipe, x and y start out being dependent and only become independent after conditioning on the middle variable, a collider is the opposite. In a collider, x and y begin independent, okay, and they only become dependent when I condition on the middle variable, in this case c. Okay, and so now that's depicted here. X is not independent of y once I condition on c. Okay, and the one of the consequences of this then in regression is that if I'm unclear about my causal structure, and I accidentally include a collider as one of my regression variables, I will all of a sudden induce a relationship between x and y, and I may then say, or I may then conclude that x is a cause of y, but it is not a cause of y, right? It just happens to share a common effect with y. Okay, so colliders are well, they're a little bit scary, and it's something that needs to be aware of. That they need to be aware of as you're including variables in your regression. Okay. And then finally, there's this descendant. The descendant is, it's a little bit amorphous. So a descendant is just simply the effect of another variable, right? So here, this is a descendant of a collider, right? Z is the collider in the depiction here, and then there's this descendant D down here. Okay, and so if I condition on D, because D contains information in Z in this case of its parent, then conditioning on the descendant will be similar to conditioning on the other variable, right? It won't be exactly like it. It will probably be a weaker version of it because there's only going to be some information from Z that's contained in D, okay? But nevertheless, it is like conditioning on its parent or its cause. But so just to continue on this, so we could also have a descendant here in the pipe, right? It could be, you could have M or Z in the pipe could have its descendant, and conditioning on that will be similar to conditioning on the middle variable. And similarly for the fork, if we had a descendant coming off of the Z variable in the fork, conditioning on that D would be like conditioning on the fork. Okay, so that is it.